Hello students, this is Dr. Faizan Mirza. In this video, I'll be covering a question related to distal tubule and proximal tubules of nephrons and how their lumen diameter and their tubule diameter varies. And the student was actually trying to see how the lumen diameter changes as the actual diameter is changing, or is there any change in the two type of tubules or no. This question deals with t-test as well, so I'll be covering that. And this question came in May June 2008, paper 5. At that time we used to have just one variant, so they were not many variants at that time. So after going through this video, I would recommend that you open up this question and try to attempt it yourself as well, so you actually know how much you gauged or what were you able to comprehend from this video. Otherwise, the practice from P5 will be not very useful if you don't start to attend these after watching every video of a particular question or set of questions, because that's the only thing that can help you ace P5. Now, coming back. So, question 3, figure 3.1 is a section of a human kidney. This is a section shown, and you can see these large spherical structures. These are the nucleus, and this empty space, this is the lumen of those tubules. And you can see some fairly circular structures with the brush borders, and these are proximal tubules. The ones which do not have the brush borders and are still very thick in a similar way will be distal tubules. So what actually the student was doing, a student investigated the proximal convoluted tubule and the distal convoluted tubule of the human kidney using a microscope and a slide showing similar details in the one as the one shown in figure 3.1. This is the figure 3.1 that I've just gone through. The mean diameter and the mean lumen diameter of 20 cross sections of each type of tubule was measured as shown in figure 3.2. So figure 3.2 shows to you that this is the actual diameter, the entire width of the tubule, and the lumen is the student assumed it to be a fairly, you can say, spherical structure or fairly smooth surface and a regular lumen, which is not the case in tubules though. But this is what the student assumed, that, okay, I'll take this much of the lumen as the diameter of the lumen and this much as the whole width of that tubule. Now, what the student did, the student, what was the student doing? The student took two type of tubules, proximal tubule and the distal tubule. So two type of tubules, and he or she actually took 20 observations of each. So small n for PCT was 20 and small n for DCT was 20 as well. So this is paired data. Whenever you are using various values of various you can say observations of one kind, and then calculating mean of that. For example, if 20 tubules were measured, the student calculated the mean diameter of all the 20 of PCT. Then if he or she then took 20 DCT, then the student took mean of those as well. So whenever you are using mean of certain data, this means the data is continuous. And whenever the data is continuous, whenever you are using mean to be calculated, such data qualifies for t-test. Now, t-test is a statistical test which is used on continuous data, where you actually compare whether the difference in the mean of the paired data is significant or not. We calculate a t-value. There's a formula which comes, and you have to just use that formula. At times they don't give the formula, they just give you the t value, for example 2.09, something like this. The value of t will be provided to you. Using the table, you will be asked to find out the critical value, and the critical value is taken at p 0 less than 0.05, where you compare your critical value and the t value together. If the t value is greater than the critical value, it means that the difference in the mean is significant and it's not due to chance. If your t value, on the other hand, is less than the critical value, in that case, the difference in the mean of the paired set of data is not significant and it's purely due to chance. Now, in this case, let's move forward. So what does the student do? The student, the results of the investigation are shown in table 3.1. The tubule diameter and lumen diameter are mentioned. Mean diameter and the standard deviations are provided. Proximal tubule, distal tubule, lumen of each as well. Now these values are provided to you. This is the mean diameter of the proximal tubule provided with the standard deviation. So this is like 65 plus minus 0.89. because the standard deviation tells you the spread of data around the mean value. Similarly, for distal tubule, it will be 35 plus minus 0.99. Now, if you compare the lumen diameter, it would be like 22 plus minus 2.26. And similarly, for distal tubule lumen diameter, it would be 20 plus minus 2.27. So at times they give you this type of data in the table, or at times they give you a printed table of this sort. So you should know what the mean and what the standard deviation means and how they can be written together. The next thing they're asking is explain how the student measured and calculated the actual diameters of the tubules. Now you need to recall your AS practical skills and how the actual diameters can be calculated. Simply, you will use IP's graticule that had been calibrated using the stage micrometer. Kidney sections were then viewed using the same eyepiece graticule and the microscope at the same magnification. So this will get you 2 marks. Now, since it's mean mentioned, so you have to mention that you actually were using various sections or various tubules were being viewed and then measured because it's mean here. Coming back, state how the standard deviation indicates the reliability of the results for the diameter of the proximal and the distal tubules. What do you mean by reliability? As already discussed, reliability, whenever they will be asking for reliability, they will be discussing standard deviation, or they will be asking you for standard error, or they will be asking you for the 95% confidence intervals. So these are the three ways in which the questions come for reliability. Or at times they ask you to just compare these values, look for the overlaps, how small and the large values are. So in this case, standard deviation values are provided. So you will look for reliability using the standard deviation values. You can see that the standard deviation value, as already know, you should be knowing, the standard deviation shows the spread of data around the mean value. We'll quote what standard deviation actually tells you. We'll state that. Now, we also know that if the value of standard deviation is small, it shows that the data is more reliable and it is less varied. So if you compare the values here, 0.89, 0.99, it means that the data is pretty much reliable and less varied for the tubules. But when you compare the lumen diameter, the values of standard deviations are large. When the values of standard deviation are large, it means that the data is less reliable and more varied. So coming back, this is what I was telling you about, that the value of t may be provided to you or you may be asked to calculate the value of t. In this case, they are saying a t test was carried out and gave the value t to be t 2.09. Now this value of t is provided to you, calculated. You don't have to calculate it. Table 3.2 shows the critical values at p less than 0.05 for the t-test. These are the degrees of freedom and the critical value is shown to you. The number of degrees of freedom is 38. They haven't asked how the degree of freedom was calculated. Now, how the degree of freedom is calculated in t-test. Whenever we actually are doing t-test, we use the formula for degree of freedom n-1 and n-1 because we are using paired data. Paired data means you have a set of observations of data of one set and another set. Both the observation sets had 20, so you will subtract 1 from each. So this comes out to be n minus 1, which means 20 minus 1, together with n minus 1, another set of data, 20 minus 1. So 20 minus 1 plus 20 minus 1 gives you 38. The way the degree of freedom is calculated for t-test is different as compared to how you calculate the degree of freedom in chi-square test. The degree of freedom provided to you already is 38. You were not asked to calculate this. I'm just explaining this to you because you should know how to calculate the degree of freedom. In other questions, they do ask you to calculate yourself. State and explain the meaning of these results. So for the degree of freedom 38, we will then look for the critical value of t. Now, if you look at the table, 18, 19, 20, 21, all these are degrees of freedom. We need to come to 38. Now 38 is not provided. You are given 30 and then you are provided 40. So using 38, we will go for 40, which is closer to 38 and not 30. For 40, the degree of freedom 40, the critical value provided is 2.02. Now, what does this mean? Your calculated value of t is 2.09, which means your t value is greater than the critical value. The critical value in this case being 2.02 and the t value being 2.09. So whenever the t value is greater than the critical value, it means that the difference in the mean is significant. It's not due to chance. So this is what you will state. Since the calculated t-value 2.09 is greater than the critical value 2.02, the difference in the mean diameter is significant and not due to chance. That's what you will be saying. If we go further, the question further asks you, based on the findings of the t-test, the student concluded that the difference in the lumen diameter was due to the thickness of the brush border. You can recall your content from the chapter of homeostasis that we discussed that in the proximal tubule, there is a brush border in the tubule. There are columnar cells that have microvilli, which actually are protruding into the lumen. So the proximal tubule, somewhat, it looks something like this in the section. So these are the individual cells of the proximal tubule. So this is how the microvilli will be there in the cells, and the microvilli will be there because these are the nuclei of the cell, the columnar cell that are making up the PCT. This is a section of PCT, the proximal convoluted tubule, and this is the columnar cell, the columnar epithelial cell of PCT. You can see this structure here, or very well I can point out it here. This is the brush border. This is the brush border. The brush border is actually the microvilli, which increase the surface area for reabsorption. You can recall a bit of theory from there, although not very well required in this question, but yes, relevant to the answer that we have to find. So the question they asked is, based on the findings of t-test, the student concluded the difference in the lumen diameter was due to the thickness of the brush border of the columnar cells on the proximal tubule. Evaluate to the extent to which the information provided enables a valid and the reliable conclusion to be drawn. So what can you say? You can say that the student measured 20 tubules. So, and the student did calculate mean to remove the anomalous reading. The standard deviation was calculated and t-test was applied as well. So yes, it is a valid and a reliable conclusion because number of tubules tested were not 1, 2, they were 20. And t-test was applied, anomalous reading were removed because the mean was calculated, and the standard deviation and t-test were used as well. So all these means that the eventual outcome of this would be reliable. At the same time, they're asking you suggest one reason why the student's conclusion may not be valid. Why may it not be valid? Because the proximal tubule lumen is not as regular and uniform as the student assumed in figure 3.2. You can see in figure 3.2, the student assumed that this is how the tubule diameter looks like. Whereas we just recall that the proximal tubule is having brush border, and because of these brush border, the lumen diameter will not at all be uniform throughout. And when it's not uniform throughout, so you cannot very well say that it is the same kind of diameter in every dimension. If a person starts to measure it along this width, the diameter will come out to be different. If you include the edge of the brush border, it will become different. If you take it from the top of the brush border, it would be different. So that's why the result may not be valid. So, although the question this had 8 marks, but this question was a very significant question considering that it came from a topic which mostly is not included in MP5 somehow. But yes, it's worth getting your theoretical and experimental knowledge tested. I hope that was helpful for you. That's it from my side. Thank you so much.